Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics, that is a very important properties of a aggregate, whether it's a coarse aggregate or fine aggregate, that is porosity and the absorption. And it is directly impacted on the concrete stain, durability, and everything. So it is very much important to know about the porosity and the absorption. So what is SSD condition, what is oven dry condition, what is a moist condition. Today I'm going to discuss about each and everything in detail. So stay tuned until the end to get the full information. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, we'll get immediate notification. So let's jump into the subject, that is porosity and absorption of aggregate. First, we need to know what is porosity. Porosity is a measure of the void or the empty spaces in the material, and it is expressed as a percentage of the total volume of the material. So what is that? We all know that there is a void in between two particles of any material. So what will be the void percentage? That is measured in a percentage, and it is the porosity. So what is happened? It indicates the capacity of the material to hold water or other fluids within the void. So what will happen in the concrete whenever we are adding water? These voids will be filled with the water. So in order to get the right proportion of the water, we need to know the what is the void percentage or the moisture percentage. That is why this porosity is very much important. So what is the characteristics of porosity? First thing is volume of void, the ratio of the volume of the void to the total volume of the aggregates. That means the total volume and the volume of the voids is the volume of the voids, or the ratio. So what is the impact on material properties? High porosity can reduce the strength and durability of the material, as it allows more space for water and other substance to enter. So if the porosity is more, that means it can impact the strength and durability. So we need to choose the material that way that the porosity will not be that much. Then what are the relevance? There is importance for understanding the water absorption, permeability, and durability of construction material. That is the problem, that whenever we are adding water into the mix, two things can happen. If the water has more water, it will release into the mix, or it can absorb the water from the mix. So either way, it become the water content in the mix can be more or can be less, which is more. Both the cases it is not accepted, because it will impact it directly on the strength and the durability. So that is why we need to know what is the void percentage, what is the water moisture percentage, and how it is calculated. That is, formula of porosity is volume of void by total volume into 100%. That is, if our sample has 20 cubic meter of voids in a total volume of 100 cubic meter, the porosity will be 20%. So it is always expressed in the percentage, that is total volume to the voids. Next, first we know that porosity. Now what do we to know? That is, what is absorption? Absorption is the ability of a material to take a fluid, typically water, within its pores or void, and is usually expressed as a percentage of the dry weight of the material. That means how much water it can absorb. That is the into the pores or void, that is the water absorption or the absorption capacity, and it is expressed always in the percentage of the dry metal, not the wet metal, is the dry. So it measures the amount of water absorbed under specific condition. So it is why it is important, because again, whenever we are adding water into the mix, if the moisture content is less, then it will absorb the water from the mix, or if it is the moisture water aggregate, it will release the water into the mix. Again, the both the cases, the strength and durability will be a concern. That is why we need to know what is the absorption capacity of the moisture. So what is the characteristics? The capacity of an aggregate to absorb water into its internal pores, that is the water intake. So it will intake the water and it will fill the voids. So it will take the water from the mix if it is not fully occupied by the water, or else if it is over occupied, it will release the water. Then what, how we can calculate? Absorption is calculated by the weight of the water absorbed divided by the dry weight of the material, often given as a percentage. That means how much water it can take into its pores or voids, that will be always measured as a percentage. Why it is relevant? Already discussed that it's a critical for determining the water demand in concrete mix design and for understanding the potential freeze and thaw cycle damage in the aggregate. Now, what is the formula to calculate the characteristics? That is, water absorption is weight in wet condition minus the dry weight divided by the dry weight into 100. So example is, if an aggregate sample weighs 150 grams and when we weight and 140 grams when it is dry, then the absorption will be 150 and or minus 140. This is the water percentage divided by the dry weight, that is 140. It's become 7.1%. So these are the porosity and the absorption. Now, why it is important in the concrete mix design, that we need to know. Different stages of the aggregate depending upon the porosity and the water absorption capacity. So there are four conditions can be arise in aggregate, that is SSD, that is surface saturation dry condition, air dry condition, oven dry condition, or the moist condition. So whatever the aggregate, it can take moisture. So according to the moisture content, we can classify our aggregates in a four condition, that is a SSD, air dry, oven dry, and moist. Now, first, what is SSD condition or the surface saturation dry condition? The condition of an aggregate in which the permeable voids within the particles are filled with water, but the surface of the particles is dry. That means whatever the voids in that is filled, but the surface is dry. That condition is surface saturation dry condition. Why it is important? If the aggregate is in SSD condition, that means neither it will take water from the mix nor it will release water to the mix. So it is the SSD condition. So whatever the water we calculate, we can get exact that amount we can add into the mix. So that is why we need to know what is the condition of the aggregate. So first condition is the SSD condition. That means in which the permeable voids within the particles are filled, but the surface particle is dry. So the aggregate does not absorb any more water. There is no free water on the surface of the aggregate. That means neither, as I discussed, neither it will release nor it will absorb. So these are the surface saturation SSD condition, surface saturation dry condition. Next condition is air dry condition. The condition of an aggregate in which the surface is dry, but the internal pores may contain some moisture. That means it is not measurable that how much air void is filled or how much air void is not filled. That means its surface is dry, but it can be absorb water inside the pores or the void. So that is called the air dry condition. The surface of the aggregates particle appears dry. Some moisture is retained within the pores of dry or aggregate. So some moisture can be possible inside the pores. That is the air dry condition. Then what is oven dry condition? Oven dry condition is that the condition of an aggregate in which all the moisture from the aggregate has been removed by heating in an oven at a prescribed temperature, typically 100 degree plus minus 5, until a constant mass is achieved. That means we are drying it and we are releasing all the moisture from these particles. That means there is no moisture, neither is a free moisture, neither is the inside the pores, nothing. So it is completely dry. That they call the oven dry condition. All internal and external moisture is removed, the aggregate is completely dry. So if we are using oven dry aggregates, that means we need to consider that it will void within the pores, it will the moisture. So whatever the condition, whatever the moisture condition, what is the moisture capacity, that also we need to calculate if you are using oven dry condition. But usually it is not happening. We are using the moist condition. That is the next part. That is the condition of an aggregate in which both the surface and the internal pores of the aggregates particle contain moisture. That means in SSD condition, what you are saying, that means voids or pores are filled with water, but surface is dry. In air dry condition, that surface is dry, but it may contain some water inside the voids. And oven dry, there is no water, internal or external. And the moist condition, that means the all voids and pores are filled and the surface also have the moisture. That is the moist condition. And usually whenever we are getting aggregates, we are getting in this condition, that is a moist condition. That means this SSD condition also is there. That means internal voids is already filled and the surface water is also there. So the surface of the aggregate particle has free water. The internal pores are partially or fully filled with the water. That is called the moist condition. So these are the four conditions according to the absorption can be found in aggregate, that is SSD, air dry, oven dry, and moist condition. So let's see in a pictorial schematic representation how this is happening. Okay, let me zoom in, then it will be okay. Let me zoom in. Okay, see, these are the four conditions, that is the schematic representation. Here it is bone dry or the oven dry. That means the all moisture is the surface moisture and internal void moisture is not there. That means there is no wet, no water. So it is completely dry. Now in this condition is the air dry condition. The surface is dry, but there are some particles or the some void, there is a water, that is the air dry condition. Now then SSD condition, saturated and surface dry condition. What is happening? See, the surface is dry but the internal pores are already filled in fully, so that is called the SSD condition. And what is the moist condition? These are the internal pores is also filled and the surface also contain the moisture. So these are the schematic representation. It is oven dry, this is air dry, the SSD, and this is moist. Now, what is the total water? Total water is that in internal, that is SSD condition water, plus the moist content, that is the surface water. See, here it is the free moisture content. See, whatever the water inside the pores, that will not react with the cement or it will not absorb from the cement or the mix. But whatever the free moisture, that will be a contribution towards the strength gate or inside the mix. So that is why these are the free moisture. So it is oven dry. When it is start accepting water or absorbing water, it is coming in the air dry condition. And what is the fully pores is developed, that is the SSD condition. And again more water it is absorbing, then it will be the moist condition or the surface moist condition. And this moisture is the free moisture. We need to know that whatever the free moisture in a aggregate, because if this free moisture will start reacting with the cement, so there will be a more water if we are not adjusting or correcting the water content according to the moist condition or the water absorption capacity of the aggregate. So these are the four condition: bone dry, air dry, SSD, and then moist condition. So I hope it is clear. Now next is what is the comparison table. So there is a small comparison table in between moisture condition, SSD, and other things. So what is that? SSD condition is permeable voids filled with water, surface is dry, that we will discuss. Then characteristics: no more water absorption, no free water on surface. So in SSD condition, whatever the void is filled, neither it will release water into the mix or it is absorb the water from the mix. So it is a perfect condition. Consistent state for calculating water content. So if we are in selecting our aggregates in SSD condition, that means we don't need to calculate the moisture content. But in reality, we are not getting the SSD condition. We are always getting the moist content condition. That means the moisture content is there. That is why we need to calculate the moisture content. So then is oven dry. Then all moisture removed by heating is an oven until constant mass. Completely dry, no moisture in or on the surface of the aggregate. Determine total moisture content and absorption. So that whenever we are using oven dry, we need to calculate the water absorption capacity plus the whatever the moisture content, that because it will absorb the water. If we are using oven dry aggregate into the mix, it will absorb the water. So that means water content to be more according to the water absorption capacity. Then air dry, surface is dry, internal pores contain some moisture. That means it contains some water, not the full. Then surface appears dry, some internal moisture retain. Approximate moisture content before use. So that will be an approximate calculation, because we don't know how much percentage of void is filled or how much percentage is not filled. So accordingly, we need to do the moisture condition. The next category is moist condition. This is the ultimate condition, but we are getting aggregate in this condition itself. Surface or internal pores contain moisture. That means the internal voids also, and the surface is the moisture. And then free water on surface, internal pores partially or fully filled, reflects the actual state of aggregates and mixing, because this is the actual state. We are getting water aggregate in this condition. That is why we need to calculate the moisture content. According to the moisture content, we need to adjust our water content on the mix. So that is why this moisture content and the water absorption and the porosity is very much important. We, in order to get the right kind of trial mix or right kind of proportion of the mix. So these are the all about the porosity, absorption, and SSD condition and the moist condition. I hope you find this useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you'll get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about construction and quality control, please let me know. I will come with more content like this. And thank you once again for watching me.